Hello everyone, welcome back. So we are solving the GATE 2017 solution. So in today's agenda we have two subjects, plant design and economics and chemical technology. So we will start with plant design and economics today. So as the first question is an LVDT, it is given the linear variable differential transformer is used for converting. So we are asked that LVDT is an instrument which is a transformer which is used for converting. So answer for this question is displacement to voltage. This is the direct question. There is nothing to explain for this question. Displacement to the voltage is the direct question. So answer for this question is A. The next question is a bond has a maturity value of 2000 rupees at the end of 4 years. So we are given that maturity value is to 20,000 rupees at the end of 4 year. So the compound interest is given and the rate is 5% per year. So we have to find the initial investment to be made. So we know that the amount for this compound interest is equal to principal into 1 plus I upon 100 to the power n. So here n is given equals to 4 years, and I or R, some people write is R also, it is R also. So it is 5% here. Now P we need to find, and amount is given maturity value of 20,000. How we can understand what is maturity value? Already we know that sometimes we see about the life insurance. So life insurance, after some time the policy get mature. So this maturity value means final value. So after final installment, the amount increased up to 20,000. So final amount is 20,000 rupees. So here we have amount equals to 20,000 equals to P1 plus 5 upon 100 to the power 4. So when we will solve this question, we will get P equals to 16454.0. So this is the final point 0. So this is the final answer for this question. It is coming in the range which is given by GATE 2017 official answer. So this is the final answer. The next question is the total cost for an equipment is given in terms of operating variables x and y. So this is the equation given. Now we need to find the optimal value of t. We need to find the optimum value of t, round up to 1 decimal place. So optimal value of t can be found by finding the maxima minima. Definitely if we have the minima here, so this will be the optimal value. So we will find the differential for this equation. So how we can find the differential equation? So this ct is given. Now if we will divide it, if we will differentiate it with dct upon dx. So if we will differentiate it with x, we will get 2 minus 1,2,0,0,0 by yx square. So we got this, and definitely this differential will be equal to 0 at minima. Now with this we got yx square equals to 6,000. So that's it. Now we will differentiate the same equation with y, dy equals to, so what we will get, 2x will be equals to 0, then we will get minus 1,2,0,0,0 upon x y square, and this y will be equals to 1 and 5 will be equals to 0. So this is, since this is equals to 0, so after solving we will get x y square equal to 12,000. So we got x y square equals to 12,000. Let's say this is equation number 1, this is equation number 2. So when we will divide equation number 1 by 2, we will get x upon y equals to 1 by 2. So this we got x upon y equals to 1 by 2, or you can say y equal to 2x. Now let us substitute this y equals to 2x in equation number 1. So what we will get, 2x cube equals to 6000. We got 2x cube equals to 6000 or x cube equals to 3000. Now on taking this cube root, we will get x equals to, we will get x equals to 91 point, sorry, 14.42. So x is equal to 14.42, and y we will get on keeping this x here, we will get y equals to 28.84. Now we got the value of x and y, and when we will put this value of x and y into this equation ct, we will get the final value of ct, which will come out as 91.52. so this is the final answer for this question, 91.52. so the optimal value ct for this equation, it came out to be 91.52. so that's it for process dynamics, process design and economics part. Now the next come is chemical technology. So in the chemical technology, the first question came is the DCDA, double contact double absorption process is used for the manufacture of. So this double contact double absorption is used for making the sulfuric acid. This is again the direct question. If you know sulfuric acid, in the sulfuric acid contact process is used, double contact process is used in order to make the sulfuric acid. So B is the final answer for this question. Now the next topic is the cost of new pump. Again, sorry, this is the question for process design and economics. The cost of new pump is 24,000. The pump for the has a useful life of 10 years. Salvage value is 4,000. Assuming the straight line depreciation, the book value of the pump at the end of 4 years rounded to the nearest integer is. So we are asked that, we are given with that cost of new pump is 24,000, salvage value is given, useful life is given, depreciation is given in terms of straight line depreciation, and after 4 years what will be its value, it is asked. So how we will do this question? We will write the depreciation for straight line is equals to V minus Vs, value minus salvage value upon N. So it is equals to 24,000 minus salvage value is 4,000, salvage value is 4,000 upon N is equal to 10. So we will get it equals to we will get it to 2,000 rupees per year depreciation is going on. So depreciation is equal to 2,000 rupees per year. Now we are asked that after 4 years what will be the value. So after 4 years what will be the value of new pump? So definitely 24,000 is value of right now we have the pump value of 24,000, and after 4 years what will be the value? 4 into 2,000. Yes, so we will get the answer equal to 16,000 rupees. So this is the final answer. What we did, we found the depreciation is how much every year the value is decreasing, and we found it to be 2,000 rupees. So every year the pump cost is decreasing 2,000 rupees. So today it is for 24,000. So after 4 years it will be 24 minus 4 into 2,000. So which is equal to 16,000 rupees. So that's it for this question. The answer is 16,000 rupees. So now next question is match the following. Now for the polymerization process it is given. So we need to find the correct set of combination. So free radical polymerization, the first is given free radical polymerization, second is Ziegler-Natta, third is condensation. So we know that condensation reaction occur for PVC, for free radical polymerization occurs for PVC, and Ziegler-Natta is for polypropylene. Condensation polymerization occur for nylon. This is the basic thing that we found. The condensation polymerization is used for nylon 66. When we add 2 compound, we get the nylon 66. Adipic acid plus one more compound we add, we will get nylon 66. So this kind of reaction is condensation polymerization. So in this condensation polymerization is made for nylon 66. So we got R is equal to first. So we have R equal to first only in the B option. So this is the correct answer. So Ziegler-Natta polymerization is used for polypropylene. This is also the basic thing, if you know that polypropylene is made for Ziegler-Natta polymerization, and third one is free radical, which is made for PVC, to make the PVC. So that's it for this question. The next question is, the purpose of methanation reaction is used to in ammonia plant is to. So methanation reaction, this is the question you can do only when if you know the methanation reaction. But yes, in methanation reaction definitely the methane will be formed, CH4 will be formed. Yes, so CH4 plus CH4 will be formed. So CH4 will be formed only when we have some carbon plus hydrogen. So carbon plus hydrogen if we have, then only we can make the CH4. So this is methanation reaction. So obviously in amination reaction we form ammonia. Similarly in methanation reaction we will form what? Methane. So how the methanation reaction will form? If there will be methanation reaction, methane will be formed. So definitely the amount of hydrogen in the product cannot be increases. Why? Because the hydrogen is in reactant. Hydrogen will be in reactant. So this hydrogen in the product cannot be increased. So definitely this option is wrong. Now, in order to remove sulfur, as it is a catalyst poison, so there is no sulfur taking participating in this reaction. So this option again went wrong. Next is utilize methane as a catalyst for ammonia synthesis. So this you can say is a classical distractor, that utilize methane as a catalyst for ammonia synthesis. Yes, it can be the answer, but here it is not the answer, since the reaction is CO plus H2 gives CH4 plus H2O. Some kind of this type of reaction is there for methanation reaction. So it is used to remove CO as a catalyst poison. So answer for this question is CO. You can definitely remove this thing and this thing. And methane, utilize methane as a catalyst for ammonia synthesis. There is no ammonia synthesis here occurring here. So there is no ammonia synthesis occurring here. So this option also goes away. So only we are left with A option, and A option is the correct answer. So if you don't know the methanation reaction, then also you can predict what will be the answer. But don't do this thing, because it will cut your there is some negative marking, and it will take your 1/3 marks away. But yes, you can find the answer in this way also. So the next question is again the match the following, when we need to find the correct set of combinations. So we are given with fluidized bed, multi-stage adiabatic reactor with interstage cooling, front dryer mill, and diaphragm cell. So in this question we have this front dryer machine. This front dryer machine, 4-dryer machine, is used to bake paper. I know this thing, that it is used for baking the paper. So I will go R with A. So here if I have R with A, then these two options are gone. Here the two options are gone. Now the diaphragm cell is used for sodium hydroxide manufacture. No doubt in that, because diaphragm cell as well as the nickel catalyst is used for making the sodium hydroxide manufacturing. I read this in Dredden. So S will go for second. So here also S goes for second. These two options again can be correct. Now we are left with fluidized bed and multi-stage adiabatic reactor with interstage cooling. So the answer for this question is will be the fluidized bed is used for catalytic cracking. Definitely we know fluidized bed catalytic cracking. We already studied this topic in octave 11 spile, or you can say chemical reaction engineering. This is very simple basic, that there is fluidized bed catalytic cracker. Fluidized bed catalytic cracker at any petroleum refinery or any petroleum industry. Fluidized bed catalytic cracker is the important equipment, and many students have been gone through it, or maybe they know about it. Fluidized bed catalytic cracker. So P will be equal to 4. So here A answer is correct. P equal to 4, Q equal to 3, R equals to 1, and S equals to 2. So Q equals to 3 means a multiple adiabatic state with interstage cooling, and that goes with SO2 oxidation. Definitely, again, we have already seen that there was in SO2 oxidation, there is contact process used, and we said it is double stage, double contact process. So double type contact process means interstage, there will be given interstage again in that. So you can think that thing also, that Q will be equal to, Q will match with third one. So answer for this question is A. So that's it for chemical technology and process design and economics part. So for more such video, you can subscribe the Gyanve channel. And if you have any doubts or suggestion or any clarification, you can comment us below, or you can join our Facebook group Gyanve. So you can post there your any query about any of the subject. We will definitely be there to help you. Thank you. Thank you very much.